do some screen sharing. It never catches the... Oh, it's not catching my... every time. Okay, let me try this again. Please, can you find my my PowerPoint? I'm glad this worked yesterday because it's not working today. Oh well, the entire screen it is. Sorry about that. So let's do share, and I'll quickly pull this up so you don't see the mess of my tabs. Okay, so I can't see you anymore. I'm hoping you're listening to me. If not, just crash into the stage. So as mentioned, my name is Cristiana. I'm going to be talking to you quite a bit today about evaluation and modeling as well, but in this case of agent believability. So to give a bit of an introduction, essentially agent believability is quite a challenge for human-computer interaction and artificial intelligence. And it can be used to improve many scenarios, not only video games, but therapy, robotics, and so on. My focus is more towards video games, especially in assessing and modeling agent believability. So we're going to assessment first. So why assessment? Well, it is pretty important. It kind of helps us arrive to standardized solutions if done properly, and these standardized methodologies are essentially what could potentially give you reproducible results. God, that went bad. But it is a bit complicated. There's no really accepted description to what believability is, and that complicates that task a lot. But overall, the definitions people mention a lot tend to be a balance between predictability and randomness, and obviously the ability to learn, which is something we do. However, context gets left behind at times, and we are going to come back to that. So in video games, they've defined believability more into two main areas, which is character or player believability. The character is when you have like a single player and you have NPCs, so they're autonomous and they're not being controlled by a player, but they kind of behave as you're expecting it to. With player believability, you don't know if the agent is a person or not, but it gives you the illusion that it is being controlled by a person. So there has been, just going to be also a quick overview of previous assessments here. There has been quite a few of them, and it has ranged from shooters to platformers. Even Pong, believe it or not, has had one done with this. So there's plenty of examples going on there, and these are and the thing they had in common was essentially that people are developing AI, and essentially they tested this as they asked that it is believable, this is not believable, and they were mostly, some of the ones I showed were competitions, and they tend to be kind of focused on a Turing test like competition. Now, I'm not going to go into every single parameter, but what these things have done is that they've done it in so many different ways, and there's just so many parameters you can take into account, and the examples are there on the screen, that it's just incredibly hard to know which ones are the best to use. So this is kind of what sparked a bit of my earlier work, essentially. So because the previous attempts focused on the AI, and the assessment kind of came as a byproduct more than anything else. So the assessment's kind of glued to it, but that was not their focus. So I decided to do something a little bit different, where I focus on the assessment and more in the believability itself, so the concept and what people think about it and so on. So that means I did a little bit of my own studies, where what I did differently is that I changed the parameters. So I focused on the evaluation, and I showed in different games, also shooters and racing games in this case, and then I would showcase these videos like others have done, but I would change the parameters. This includes the time that you get to assess it, the perspectives, so cameras, the roles for the judges, the experience of even the judges. I changed quite a lot of things, and I wanted to take some conclusions on how these affect the outcome of how people perceive the believability of these agents. Now, some of my findings at the time was that, for example, stuff such as showing odd camera angles could introduce unnecessary confusion. So this means like cameras that people are not used to playing with, like a helicopter view or something of the sort. But the games you picked also mattered. So games, for example, with harder controllers to use that are more that are a bit that were not necessarily done for people to play them, but rather, for example, AI to do it, will introduce noise and sometimes made it a lot easier to spot. Also, changing the judge's role made the task harder. So if you're playing with bots, for example, you're not as focused on assessing them, whereas if you're watching them, you will be, and so you will be able to spot more things. We also seem like more experienced players were a lot harder to fool, probably because they know the mechanics of the games. And what I mean by this is also that more experienced players were showing a lot more confidence in their answers as well. So essentially, you change the test components and the results are going to change with it. And there's more. I explored the judges' reasoning behind their answers. And, for bots, usually would hear mechanical, they lack error, they don't adapt to surroundings. And for humans, like they're not picking the least optimal paths, they're bold, they're aggressive. However, this also brought a lot of disconnect with them. So the reason sometimes people gave for someone being a bot, like, oh, it's not making any errors, would be exactly the same reason someone would give for someone to be a human. And we also had some funny things happening where novice and experienced players were seen as bots because no one can possibly be that bad at the game or that good. And of course, this is gonna alter a few things. So there are other interesting points here, which is kind of what's going to spark the next part, which is that many participants compare themselves to the agent based on their judgment. Based on the judgment they did. So essentially, they would say, well, this is a bot because I wouldn't do this. Also, when asked for games with believable agents, players favored heavily character believability. So the games where they know they're playing against bots or with bots, and they will mention how they behave and, how believable they are in those scenarios, which, with some actually being very, very against having player believability. So in multiplayer games where you're not told whether or not you're playing with bots, and many mention context, which, as I said, I mentioned this in both needing believability, so some games not needing it at all, and the fact that they have sometimes even dumb AI is what makes them fun, but also in the moments. So they would say, I thought this was a bot because in this specific moment, this thing happened, and that's what allowed for my decision. So what are essentially the problems so far? So these studies obviously address some of the research and gaps in the field, but they have some limitations like everything. So they usually give a representation of believability to the whole session. So an entire bit, and they go, this is or this isn't. The Turing test-like assessment's also quite reflective. You've seen how vague the term is, and you've seen how many ways you can do this, so that doesn't help. So again, the diversity of the questionnaire parameters can give you different results, and those are hard to compare in the end. So it leaves believability assessment with quite a lack of standardized methods. And worst of all, it's a very high level evaluation. So context and specifics get lost here a lot. So what did we do to essentially tackle this? So this is where believability met effective computing. Now, affective state, which is basically the underlying experience of feeling emotion or mood, they're very fuzzy concepts as well. Much like believability, they often are represented as continuous dimensions like pleasure, arousal, dominance, etc. So affective computing has been focusing on modeling them in a time continuous matter. And there's many tools to do this, specifically Pagan, and I mentioned this because I then ended up using it on my new study. So Pagan is just a tool that it's online, it's free, everyone can use it, and essentially you add videos to it, and you can attach Google Forms as well to make a questionnaire, and you pick what are you measuring. Like the example I show there, it has like arousal, and then you have different tools to measuring it over time, over the video. So it's going to show you a video, and then you can every moment go on and keep assessing or evaluating what's happening depending on what you want to measure. So we did this for believability. we basically integrated a game called Mazing. So it's not a oh, missing the word. So essentially in this game, what you can do and your enemy can do are different. So you can shoot, you can drop bombs, and the idea is that you kill your enemy, but your enemy can only chase you, but he will try to chase you, catch you, and touch you. And if it does, then you respawn again. You lose points, and so on. And it has like a hearing radius. It has like a visual field, and that's why I left a image there so you could see it. So we integrated it with Pagan. And what happens that I gave this to people. People will play a session. This will be recorded and gets played back to them. Now, while it is played back to you, the video, you then tell me how believable you found the opponent to be in the given context, because this is important. And you can do it for every moment. Now, some participants were given rank trace, some were given B trace. Rank trace is the top annotation tool where essentially you use your cursor and you change up and down when you think it suddenly became more believable or less believable. And B trace is more of a discrete here one, where you say yes, no throughout the session, depending on what you think. And you repeat this essentially one more time. So you do 2 sessions. And the reason for this is because at the end, I asked you which video you thought was the most believable, the one that had the character, the opponent that was most believable, and some demographics. So essentially, what kind of data did I take? I took telemetry data. So this is a total of 55 features. This includes player, agent, and general features like score, positioning, health, how much long has it been, how many times you click buttons, all of it. And your annotations, of course, for beat trace and for rank trace. So these get all 3 sampled and aligned with each other. And essentially, we got a few different decent numbers. We got 26 for rank trace and 24. And the data you see there is the data points that we get for all the videos. Now, with the overall results, because I can't possibly go time by time, result by result, because these were very long studies, and I will be leaving you the papers later. What we found was that there was a correlation between the choice of the video between both and the annotations that you did, more so in B-trace than A-trace. We also found a lot of significant linear relationships between what was the perceived believability of the agent and the individual gameplay telemetry features. Again, we found a lot more for B-trace than for rank trace. We kind of think it was more intuitive to use B-trace really for this specific scenario. Now, these are basically all the telemetry features that we use. I'm highlighting the top 10 that had the highest correlations, essentially, because otherwise it's going to get confusing talking about all of them. So you can see in green B-trace, yellow rank trace, and orange shows both. Now, some of the results were surprising of what actually is related to believability or not. Now, we don't show all of them. For example, bot health and bot position X, which is from rank trace, is one of those that has significance in B-trace as well. It's just that in B-trace it was a lot lower on the level of correlation. And with the B-trace ones that show their like player health and input diversity, we did see input diversity and rank trace, but not player health, surprisingly. And despite seeing some things that seem obvious, like the bot seeing the play and chasing the play being correlated with believability, we actually found some that weren't. So essentially, all of them seem to be more related to movement rather than specific things. Like, for example, bombs drop don't find any correlation, or even the bot searching turn. So the amount of times the bot ends up losing and searching were not correlated with believability at all. So this, and again, we could stay here for hours talking about this, but essentially there's a lot you can take information-wise from the context and how this can correlate to believability. In fact, I'm going to just say that the ones that have a little minus between parentheses is like an inverse relationship. So, for example, idle time means the more the player doesn't move, the lower the believability that is perceived. We also did some modeling with this. We did a binary classification ranks with random forests, just because random forests are fast to train. They're kind of robust model for human data. And we do this again to investigate the robustness of models based on data collected through these 2 methods. And we train all this data that we used to do these models. And so what we found is, for example, B-trace predictions were, again, considerably better than the rank trace, and we were finding 70 to 72.5% accuracy on average, which is pretty decent. So this is basically the model trying to predict believability. Uh, both papers are done there because, again, these studies are very large and it's very complicated to go through everything in such a short time. I'm probably already going over. Now, things to note here is that this doesn't mean that continuous method is necessarily better. It just means that continuous annotation can capture the temporal dynamics of a certain experience. But the discrete labels will often reduce noise, which can be helpful too. Essentially, this needs more testing, and this is just another way of tackling believability. And tools like this can be beneficial for both research and industry developers. So what can you do with this? Well, these techniques can provide context and information on your player's experience, which you would want. Knowing which game features have a connection with believability can help you make decisions about a game's design, and models that can predict believability can be used to aid agents' decisions, like weights in an algorithm. Also, we get so much of telemetry and respective annotations that you can use this on any of the AI algorithms, like reinforcement learning, and using the annotations as rewards. It's an example. So essentially, you can use this more towards modeling or assessment or AI. It's pretty flexible. And you can even go beyond believability. After all, effective computing has. So the conclusion you take out of this is that it is still a pretty hard concept, all of this. But the way you evaluate things are gonna change your results. So whichever you pick is gonna depend on what you're looking for. But context should be taken into account. And these techniques need to be explored further, especially in more complex scenarios, but they have the potential to be flexible, which is something you want, especially if you're in a very fast-paced environment, for example, like the games industry. Now, finally, for a bit of a self-serving thing, I'm finishing my PhD and I'm in my last year. I'm going to leave here all my contact details so we can go to questions now. And having said that, I'm in my last year, so I am looking for opportunities after this. So if you find this interesting, come talk to me after, because I'm very open to discuss this and other things, since my interests spawn quite widely. And I think that's it. I'm going to allow now for some questions. If someone has some, I'll stop sharing just because